Imagine this. It's a quiet night in July 2025, and somewhere in the vast, star-speckled expanse above us, a silent intruder slips into our cosmic neighborhood. Not from the familiar orbits of our solar system, but from the distant heart of the Milky Way itself. Racing at speeds that defy gravity's pull, this wanderer, dubbed 3I/Atlas, brushes perilously close to our sun, offering humanity a fleeting glimpse of something truly alien. What if this tiny speck of ice and dust holds clues to worlds we'll never visit? Secrets forged in the fires of another star, billions of years ago? Today, we're diving deep into the story of 3I/Atlas, the third confirmed interstellar object to grace our skies. Why does it matter? Because in its icy trail, we might just find echoes of how life, or at least the building blocks of it, travels the galaxy. Stick around as we unpack the discovery, the global scramble to capture its image, and the mind-bending questions it raises about space exploration and our place in it. If you're a space enthusiast, a curious beginner, or just someone who stares at the stars and wonders, this is for you. Let's launch into the unknown. Picture the scene on July 1st, 2025. High in the Chilean Andes, the twin domes of the Atlas telescopes, short for Asteroid Terrestrial Impact Last Alert System, hum with quiet precision. These aren't your backyard scopes. They're vigilant sentinels, scanning the night sky for threats from space. But on this ordinary sweep, something extraordinary pings the system. A faint dot moving too fast, too oddly, across the constellations of Sagittarius. It's not an asteroid tumbling lazily in our asteroid belt. No, its path screams outsider. Hyperbolic, unbound by the sun's embrace, hurtling through like a bullet from another galaxy's gun. Within hours, alerts ripple out. Astronomers in Hawaii rub their eyes at 3 a.m. data feeds. In Europe, coffee goes cold as orbital models spin up on supercomputers. The verdict? This is interstellar, only the third ever confirmed, after Oumuamua's cigar-shaped mystery in 2017 and Borisov's comet tail in 2019. Each one a cosmic postcard, but 3I/Atlas? It's arriving at the perfect time, close enough to study, fast enough to demand action. Why the rush? Because hyperbolic paths mean one shot, one pass. No encore. As the object streaks inbound, its trajectory traces back to the Milky Way's bulging core, a stellar nursery where stars are born and die in fiery chaos. Forged there, perhaps eons ago, it's a time capsule from a place we can only dream of reaching. And just like that, the world of space exploration tilts on its axis. Amateurs and pros alike drop everything. The hunt is on. That first ping from ATLAS wasn't just a blip on a screen. It ignited a frenzy that spanned continents and time zones. Think about it. In an era where we launch rockets to Mars and probe distant exoplanets, here's something crashing our party uninvited, from light years away. Forums explode with chatter. Reddit's r/space lights up with, "Is this the real deal?" Threads. X, buzzes with number 3I/Atlas hashtags as backyard stargazers in Sydney share grainy photos from 8-inch reflectors. It's democracy in action, citizen science at its rawest. Zooniverse volunteers, those unsung heroes sifting terabytes of sky survey data, dig back through archives, unearthing pre-discovery glimpses that push the timeline back by days. Suddenly, the object's path sharpens. Its excess velocity, that extra kick proving it's not from here, locks in at over 26 kilometers per second relative to the sun. Fast enough to escape any star's pull. In Poland, a university team hijacks their schedule, squeezing in exposures between passing clouds. South Africa's observatories under the Southern Cross capture streaks that feed into NASA's Minor Planet Center. It's a relay race against the clock. Each observation, from a high school in Japan to the pros in Chile, tightens the noose on uncertainty. By week's end, over 200 data points from 25 countries paint a clear picture. 3I/Atlas is real, it's interstellar, and it's heading straight for the sun's fiery doorstep. No borders, no paywalls, just pure shared wonder. But as excitement builds, So does the pressure. Ground telescopes can only do so much. The real prize? A crystal-clear image before solar glare swallows it whole. Fast forward to July 21st, 2025, and the crown jewel of space exploration tech takes the stage. NASA's Hubble Space Telescope, orbiting 340 miles above Earth like a vigilant eye in the void. At that moment, 3I/Atlas is 277 million miles out, still inbound, but closing fast on the sun. The challenge? Imaging a faint, fuzzy comet against the blinding backdrop of our star. It's like spotting a firefly next to a searchlight. Hubble's Wide Field Camera 3, a beast of near-infrared and visible light sensitivity, steps up. Engineers tweak filters to slice out solar noise, stacking dozens of exposures to chase away the blur of the comet's sprint. Motion correction algorithms dance with the telescope's tiny jitters, aligning pixels like a cosmic puzzle. Sunshades deploy, blocking stray glare with surgical precision. Real-time sims predict the object's shift, ensuring not a second is wasted. And then, click. That single frame emerges. Not a smudge, but a revelation. A nucleus no bigger than a kilometer, sharp as a tack, wreathed in a delicate coma of vaporizing ices. Dust halo faint but symmetrical, hinting at jets sparked by solar warmth. It's the sharpest image of an interstellar object near the sun ever captured. A leap from Oumuamua's elusive shadows or Borisov's distant blur. No ground scope could match this. Atmospheric twinkle and light pollution bow out. Stored in the Mikulski archive, raw and processed, it's open to all. Pros dissecting spectra, students zooming in for the first time. Hubble didn't just snap a pic. It handed us a key to unlock the chemistry of alien worlds. But the story doesn't end in orbit. As 3I/Atlas dives deeper, Earth's view fades, and a new cast of heroes emerges. August 7th hits, and NASA and ESA drop the bombshell. That Hubble frame is official, the sharpest ever peek at 3I/Atlas. Press releases flood the wires, YouTube algorithms hum with explainers, and suddenly everyone's talking interstellar comets. NASA's words? Unprecedented detail on a galactic visitor. ESA chimes in, a reference point for the ages. It's not hype, it's fact. That pinprick nucleus, under a kilometer wide, glows against its coma like a ghost in the machine. Dust jets? Subtle but there, whispering of ices turning to gas under solar fire. For planetary scientists, it's Christmas. Models of comet evolution get a fresh benchmark. How does something born around another sun react to ours? Comparisons roll in quick. Unlike Oumuamua's weird, non-gassy silence, 3I/Atlas acts the comet part, tail, and all. Borisov had carbon monoxide hints. This one teases carbon-rich quirks. The image anchors everything, simulations of its path, predictions of outbursts. Archived openly, it invites reanalysis. What if we tweak the filters, run new stacks? Even amateurs tinker, posting deconvolved versions online. In classrooms from Tokyo to Texas, kids projected on screens, debating, could this stuff seed planets like Earth? The buzz builds a bridge between experts and everyday dreamers. Space exploration isn't elite anymore. It's us peering through Hubble's lens at the galaxy's mail. Yet as headlines fade, the real drama ramps up. Solar conjunction looms, a blackout where the sun hides our guest in plain sight. Solar conjunction. The term sounds benign, but for astronomers, it's a gut punch. By late September 2025, 3I/Atlas slips behind the sun from Earth's angle, lost in a glare so intense even the mightiest scopes go blind. Weeks of nothing, no tracks, no spectra, just a void where data should pour in. And timing? Brutal. On September 25th, a coronal mass ejection blasts out, a solar tantrum hurling particles at millions of kilometers per hour. Did it singe the comet's surface? Strip its coma? We can't tell in real time. Perihelion, closest sun approach, hits October 30th inside Mars's orbit, where heat could shatter it like glass. The stakes, sky high. Miss this, and we lose the climax of an interstellar drama. But space exploration thrives on backups. Enter the off-world watchers. Soho at L1, that sun-staring veteran, blocks the solar disk with its coronagraph, spying faint streaks. Stereo A, looping ahead of Earth, catches side angles, its heliospheric imager turning comet chaser. Parker Solar Probe and Solar Orbiter, darlings of solar wind studies, snag glimpses when orbits align, daring dives into the sun's realm paying off big. And Mars? Oh, Mars steals the show. On October 3rd, 3I/Atlas zips within 28 million kilometers, close enough for the Red Planet Sentinels to lock on. ESA's Mars Express peers through dust storms with spectrometers hungry for gas signatures. NASA's MAVEN sniffs atmospheric echoes, while ExoMars trace gas orbiter maps trace volatiles. No Earth glare here, just crisp, unfiltered views of a visitor brushing past the rusty world we dream of colonizing. Data streams back in bursts, coma composition, dust scatter, activity spikes. International pipelines hum. NASA shares with ESA, JAXA folds and radio pings. It's a symphony of robots, filling gaps with precision. The sun can't silence science, it just reroutes it. From those Mars flyby feeds and solar probe snapshots, the portrait of 3I/Atlas sharpens, and surprises lurk in the details. That coma, classic comet fare, water ice sublimating to gas, carbon monoxide tagging along, a tail fanning out like a solar sail. Spectra from Mars express echo-solar system kin, but ratios whisper differences. More carbon-heavy organics, perhaps a nod to its distant forge. No wild alien brew yet, but outliers tease. Extreme negative polarization in the dust light, stronger than Borisov or any local comet. What does it mean? Grains shaped like needles or coated in exotic ices from a star we can't name. Dynamically, steady as she goes. No rogue acceleration like Oumuamua's eyebrow raiser, just gravity's reliable tug. As of early October 2025, no fragments, no drama bursts, though perihelion could change that. Fun fact, if you scaled it up, 3I/Atlas's nucleus is smaller than Manhattan, yet it carries the mass of a mountain range and frozen secrets. Comparisons hit home. Earth's water might trace to similar wanderers. Did one like this seed our oceans eons ago? Hypothetical, sure, but backed by isotope matches in ancient meteors. Ongoing missions like these probes aren't just tag-alongs, they're the backbone. MAVEN's data, cross-checked with Hubble's baseline, builds a timeline of activity. Peer-reviewed papers brew, astrophysical journal letters, eyes a-drop soon, dissecting polarization puzzles. It's not just data, it's a mosaic, piecing together how interstellar objects remix the solar system's playlists. And for planetary defense, a goldmine. NASA's Planetary Defense Coordination Office didn't sleep through this. Even with zero Earth risk, 3I/Atlas's path a safe highway, they ran it like a drill. Tabletop sims, what if it veered? How fast to alert? Protocols sharpened, comms tested across borders. It's prep for the big one, because space exploration demands vigilance. And EO surveys like ATLAS evolve, hungry for more. Lessons? Rapid global sharing works, hundreds of eyes beat one. Open data policies shine. Every spectrum's public, sparking indie analyses. Imagine a grad student in India spotting that polarization quirk first, democratizing discovery. Future implications ripple wide. As we chase Mars colonization with SpaceX's starships, understanding these visitors guards our outposts. Could one contaminate a habitat or deliver resources? Theoretical, labeled as such, but rooted in chem models from nature papers. And the big picture? Interstellar objects like 3I/Atlas hint at abundance. Billions cruising the galaxy, per dynamical sims in science. They're not rarities, they're the norm. Our sun's a brief stopover in their eternal roam. It reframes space exploration, not just outward thrusts, but inward reflections on connections across voids. We've journeyed from that fateful July ping to Mars's red gaze, unraveling 3I/Atlas's tail. A third interstellar envoy, imaged sharper than ever by Hubble on July 21st, unveiled August 7th. Global hands, from amateurs in backyards to probes at the sun's edge, wove a net catching every photon. We've seen a comet's familiar glow laced with alien whispers, carbon quirks, polarization enigmas, steady sails through solar storms. No threats, but endless lessons for defense and dreams. Key takeaways? Interstellar visitors aren't myths. They're messengers, urging better tools, tighter teams. They remind us the galaxy's a shared highway, bustling with frozen freight from forgotten stars. But here's the kicker. What if 3I/Atlas's dust holds prebiotic hints, echoing life's interstellar hitchhike? Or if its path clues us to rogue planets, dark wanderers outnumbering stars? Ponder that as it fades outbound, unbound. Space exploration evolves because of moments like this. Curiosity conquering glare. So what do you think? Drop a comment. Ever spotted a comet yourself? Or what's your wildest interstellar theory? Hit like if this sparked your wonder, subscribe for more on black holes explained, Mars mission updates, and the next big space discovery. Check our playlist on recent space discoveries for Oumuamua deep dives. Thanks for exploring with me. Keep looking up. The stars are calling.